An example of a multifactorial disease is breast cancer. There are many genes that affect breast cancer, and the severity and risk of developing breast cancer is variable depending on gene expression levels. Two really known genes that affect breast cancer are BRCA1 and 2, which are in charge of aiding in the making of a protein that repairs damaged DNA. A mutation in these genes can lead to a 7 out of 10 chance of developing breast cancer by the age of 80, but this does not necessarily mean that if there is a mutation, it will ultimately lead to breast cancer, as some people live with the mutation and do not develop this disease. CHEK2 is another gene that helps with DNA repair, and in this case, if a mutation occurs, it can increase the risk of breast cancer by twofold. There are many other genes that play a role here, which is why it is not possible to say that one gene 100% leads to breast cancer. Lifestyle factors also play a large role in the developing of this disease, as well as the risks associated. For example, if you drink 2 to 3 drinks a day, this increases your chance of breast cancer by 20% compared to people who do not drink. Also, the more fat tissue that a person has, the higher estrogen levels and blood insulin that this person has, which are both linked to cancer, and this effect is even larger postmenopause in women. Even factors such as having your first child after the age of 30 can increase the risk of breast cancer. Even if someone is completely healthy and does not meet the criteria for high risk, there are still cases where there's a sporadic mutation in any one of these genes, ultimately leading to breast cancer.
Another example of a multifactorial disease is type 1 diabetes. Type 1 diabetes occurs when an individual's pancreas does not produce any insulin due to malfunctioned islet cells. Insulin is a hormone that helps regulate glucose levels in blood. Without insulin, sugar keeps circulating in blood without being taken up and metabolized for energy. Diabetes is a multifactorial disease where environmental risk factors may trigger the immune system to selectively destroy pancreatic beta cells, causing absolute insulin deficiency. The risk of developing diabetes is determined by genetic predisposition. Therefore, it is a combination of your genetic composition and environmental factors, such as smoking, pollution, and diet, which can influence disease progression. Scientists use genome-wide association studies to identify multiple candidate genes to dictate the function of pancreatic cells. Through genome-wide association studies, scientists have identified around 50 genes known to contribute to type 1 diabetes susceptibility. Genome-wide association studies identify genes involved in human diseases. Data obtained from these studies can be used to pinpoint genes contributing to the possible risk factors in developing a disease. While environmental factors can influence the incidence and progression of diabetes, there is still a genetic component, making some people more susceptible than others.